Okay, guys, so the second part of section 3.3, what we're doing today is we're trying to take equations of quadratics that we have, and we want to write them in this vertex form. Vertex form of a parabola is y equals a times x minus h squared plus k. To get it into this form, we can use completing the square to make it in this form so that we can then see the vertex. Okay, here's an equation. And if I want to find the vertex, do you guys remember a way I can find it even when it's in this form? Negative b over 2a and plug it back in, right? That's the way I can do this. But let's get it into vertex form by using completing the square. Here's what we do. I don't want to take the 5 to the other side. I just want to scoot it over a little bit. I want to leave a space right here so that I can complete the square. So I've got my x squared plus 4x, and I'm just going to scoot the constant over a little bit. It's still on the same side. I'm going to take half of this and square it. What is half of 4 squared? So I'm going to add 4. Now, I want to put a number here, but I want to keep my equation equal to what I started with. So if I just added 4, and I want to keep my equation equal to what I started with, and it's going to be on the same side, what do I have to put? Minus 4, correct. Now, let's double check and make sure it's still equal to what it was. I would have x squared plus 4x, that's good. Negative 4 plus 5 minus 4. Is that still 5 like it's supposed to be? Yeah. Okay, so here's what we do. We're going to look at this part right here. Now, this should be a perfect square trinomial. What does this factor down into? X plus 2 quantity squared. And what is 5 minus 4? 1, right? And now we have this in our vertex form. So what is the vertex here? Negative 2, 1. Okay? Negative 2, 1. Let's say that I'm not sure about this, and I'm at home doing my big ideas, and I'm like, I don't think I did that right. I'm going to put in the original problem, putting in the original equation. And here is the parabola. How do I find that vertex? Second trace, minimum, go to the left, hit enter, go to the right, hit enter, enter one more time, 2, negative 2, 1. See how it is negative 2, 1 like we thought it was going to be? All right, so we got it. Okay, let's do another one to make sure we've got it. We've got f of x equals x squared plus 10x. I'm going to add something here. I'm going to scoot over this 28, and I have to keep everything equivalent. All right, so what do I do to find out what I'm going to put in this spot? Okay, what's that going to be then, Sarah?
25.
Good. So if I put plus 25 here, what am I going to have to put? Subtract 25. Does everyone understand why we're doing that? I'm keeping it equal to what it was at the beginning. And this is all the same. 25 minus 25 cancels. It's exactly the same as what we started with. So we're in good shape. Now, this right here should end up being a perfect square trinomial because we completed the square. Do we know what this is going to be? What is it, Hamza? Right, so it's going to be x plus 5 quantity squared. And then we have 28 minus 25, that's plus 3. And so now can you see what the vertex is? Negative 5, 3, right? I could have done that by doing negative b over 2a, and I get negative 5. I hate though when I have to plug that back in to get that y value, you know. I always am afraid I'm going to make a little mistake. So I always use this method when I'm trying to find the vertex. I think it's faster once you get the hang of it. Okay? All right, let's do a word problem, something a little bit different. It says the area of a triangle is 30. Find the value of x. Well, they didn't give us an x value. Hold on a minute here. We do not have enough information to do this problem. All right, let's move on. I'm not sure. There must have been a picture here that didn't copy over or something. Let me think if I can make up one. Okay, here I'm going to make one up. Here we go. Here's our picture. Some of you may be able to already think of what x is, but... Okay, so if I'm trying to do this problem, the area of a triangle is 30. Hold on. I'm not sure this is going to work out the way I wanted to, but that's okay. I'll just keep going with it. So I would have to say that my base times my height divided by 2 is going to have to equal 30. So now what would I do to solve this? I'd have to multiply both sides by 2, and I'd have x squared plus x equals 60. Everybody with me? I'm just distributing this as I multiply, cross multiply there. Now, before I bring this over and take half and do everything, are there numbers that are going to multiply to be 60 and subtract to be 1? No, there's not. So I would then have to use another method. I could use my calculator. Let's talk about how we could do this on the calculator. This problem is not going to work out right because these are not going to be nice whole numbers. So let's put in x squared plus x, and let's put in 60. So if I'm solving this and I have my window set this way, am I going to see that y equals 60? No, I'm going to have to make this y max go up to like 80. I'm going to see if I can solve this. Like I said, I just made it up and it's probably not going to work out too nice. But I'm trying to find out what that point is right there. Second trace calculate that intersection. So as long as you understand the process, it doesn't matter what this answer is that we get. Okay, it's 7.26 for x. And what's the height going to be then? Yeah, so that's a problem where we could use a calculator on it, since I didn't make it so it would come out to be an integer answer. Makes sense with the process. Doesn't matter what the answer is really there. Okay, write the quadratic function in vertex form, then identify the vertex. This is a really good problem here. I want to show you this. Now, everybody listen up. We always try right now to say, okay, I'm going to take half of this and square it. But in order to use that method, this coefficient has to be a 1. It is not a 1. So here's what I have to do. I am just going to factor a 2 out of these two terms. Just out of these two terms, I'm going to factor out a 2. What would I have left? Okay, and I'm going to leave a blank, and I still have this plus 11. I want to make this so this is a perfect square trinomial. So what am I going to add in here to make it so it's a perfect square trinomial? Plus 4. But what if we do not put minus 4 here? I would actually put minus 8 here. Yes. Do you guys see why I have to put minus 8? Because I really didn't just add 4. I really added 2 times 4. So that's why I had to put the minus 8 there. And so then this is going to become 2 times x plus 2 quantity squared plus 3. And now do you know what the vertex would be? -2, comma 3. Okay? -2, 3. All right. Let's do another calculator problem and then we'll be finished. A golfer hits a golf ball on the fairway with an initial velocity of 80 feet per second. The height in feet of the golf ball t seconds after it is hit can be modeled by the function h of t equals negative 16t squared plus 80t plus 0.1. Find the maximum height of the golf ball. What do we do? Are we going to complete the square, factor, use our calculator? What do you? You could, but I would rather we do what when we have numbers like this? Calculator. Yep. When we have large numbers and decimals and things, it's best to use our calculator. Okay, you guys see if you can find the answer here. I'm going to pause for a minute. I'm just putting it into mine. I'm going to say I'm on a standard window and see if I see anything. What do I do to make it so that I can see that highest point? Hit window and then change what? Y max. It's going a lot higher than 10. I'm going to go with 100. I don't know. That might be too big, but let's see. Ooh. Yeah, I'm going to go with a little bit higher. I like to see the very top of it. So you got to be patient with these. It's going to, got to adjust that window. Okay, there we go. Did anybody find the maximum height yet? What'd you got? 100.01. Let's see if you're right. Second trace, calculate the maximum. Get close to the left. Enter. Get over on the right side of it. Enter. Enter one more time. And you are correct. 100.1. What units are we using? Feet. So 100.1 feet is the highest point of that ball, the highest level it reaches. Now, how long does it take the ball to hit the ground? Does anybody know what we do to figure that out? We want to find the x-intercept, don't we? To find the x-intercept, I can use the zero function, but I actually like to put in what? What do I want the height of the ball to be? 0. So I'm going to put in y equals 0. And what am I going to find now when I go to second trace? Which one is it I want? The intersection. Now, I can't just start hitting enter, enter, enter. I got to get close to that point where it's hitting the ground. Here's where it's hitting the ground. Do any of you hit golf balls? Yeah. Mine usually go more like that than like that. But anyway, let's see here. Okay, so 5.001. So we're going to say about 5 seconds. What if the question had been how far? Well, we actually couldn't figure out how far it travels because they don't have it in terms of x. They have it in terms of time and height. So this truly isn't the path of the ball. This is just telling us the height of the ball based on the time it's traveled. Okay? All right, any questions? So the new thing here, guys, is this completing the square in order to get it into vertex form. So this problem was the hardest one. If you get to one of those on your big ideas, make sure you go back and check that out and make sure you can do it. Okay?